So welcome to my channel again. This time around we are considering revision of YA questions, and this one was I think 2023 from YA 2023, and it's a question on circle geometry, as you can see. So the question says ABCD is a circle, as you can see, and the quadrilateral OBCD is a rhombus. This OBCD, this quadrilateral, it's a rhombus, and the question is to find T. What's going to be T? What's going to be Y? And then we have to find angle ADC. ADC. That means this entire angle here. That's angle ADC. All right. So let's quickly start. The first thing we are going to make use of, here we're going to be making use of a series of circle theorems. You understand? So the first one we're going to be looking at is the first one we say is that angle at the center is twice angle at the circumference. Angle at the center, zero represents center here. Whenever you see zero, they're telling you that that is angle at the that's the center. So the angle here, angle at the center is twice angle at the circumference. Angle T is, you can see, is at the circumference of the circle. You understand? So if this is C, for example, what this thing is telling us is that C, which is angle at the center, is twice angle at the circumference. Angle at circumference, which is T. So that means here we can put 2T. All right? Angle at the center is twice angle at the circumference. That's the very first thing we are going to be making use of. And then another thing we can do is that we know that they've already told us that the quadrilateral that is inside OBCD is a rhombus. One thing about rhombuses is that their opposite angles are always equal. You understand? Their opposite angles are always equal. So if this is 2T, it is still safe to say that this is also going to be what? 2T. That is another thing that that we can as well do. All right. That's another theory we can, another theorem that we can use. So if this is 2T and this is 2T, definitely this is also going to be what? T. All right. And then another theorem we are going to be making use of is the fact that, if you check quadrilateral ABCD, this quadrilateral, this four-sided shape, it's a cyclic quadrilateral. What is cyclic quadrilateral? Cyclic quadrilaterals are quadrilaterals, whose vertices are always on the circumference of a circle, whose corners are always on the circumference of a circle. All right, and this is a typical one of that. So what do we know about such special kind of quadrilaterals? The opposite angles of cyclic quadrilaterals are supplementary. They add up to 180. So if we add T and 2T, they must give us 180. So that is uh, what we're going to be using to calculate our T. So we know that T plus 2T must give us what? 180. What's the reason? Opposite angles of cyclic quadrilateral. I'd like for you to know that here, this is why question, and you have to put reasons why you put why you do what you do. So if you say T plus 2T equals 180, we need to put it here that that is what? Opposite angles of what? Cyclic quadrilateral. Put it there. All right. So we know that T plus 2T is 180. Definitely we know that 3T is just going to be 180, right? Which will make T to be equal to 180 by 3, and then T is going to be equal to 60 degrees. So angle T is 60 degrees. So we found our T. That's number A, our letter A, sorry. And then the next thing is to find our Y. Now, once you know that angle T is 60, automatically we know that this is going to be 2T, which is going to be 2 times 60. All right. So therefore, we know that 2 times 60 or 2T equals what? 2 times 60. That gives us 120 degrees. So this angle is 120 degrees. Another thing I'd like for you to know is that if you check the triangle BOD, this triangle, this small triangle here, you check that it actually is an isosceles triangle. What are isosceles triangles? They are triangles whose sides are the same. These two sides like this are what? Are the same. Why are they the same? Because this line that's drawn from here to here is radius. This line that's drawn from here to here is what? Is radius. You know that any line that's drawn from the circumference of a circle to the center of that circle is radius. All right. So this is radius. This is radius. That means these two sides are the same thing, which means we are dealing with what? An isosceles triangle. And one thing we know about the angles of an isosceles triangle is that the base angles are always the same. the base angles are always the same. And we know that this is 2t, that's already 120, all right? So if this is 2t, automatically that's 120. What's going to be left inside this triangle is going to be, 60, because every angle, all the angles in a, in a triangle must be 180. So this is already 120 gone out of it. So this is going to be what, 30, and this is going to be what, 30. All right. So that is that one there. Then we can easily find out why. Making use of the triangle ABD. ABD. So finding y, let's add up all the angles in the triangle ABD. We have the T here, T, which is already what? Okay, let's just put it T plus what? This angle here, y plus 30, y plus what? 30, plus this other one, y plus 30, y plus 30. Everything must be equal to what? 180. What's the reason? Sum of angles in a triangle. All right. So y plus 30, y plus 30, that's going to be, we know that t was already 60. So let's just go 60 plus what? Y plus 30, y plus y is going to be 2y. 30 plus 30 is going to be what? 60 equals 180. All right. So we have 60 plus 60, that's going to be 120. Or let me just transfer everything there. So 2y is going to be equal to 180 minus what? 120. So 2y is going to be equal to 60, right? And y is going to be equal to 60 divided by 2. And y is going to be equal to 30 degrees. So we've gotten our t, we've gotten our y. Now let's find triangle ADC, angle ADC. Angle ADC, definitely we know is this particular ADC, this y here, this 30 here, and this unknown angle here. This unknown angle here, how do we know the angle? We know that this particular shape, they said it's a rhombus, all right? And there's this line, this dotted line that goes from this corner to this corner. We know that that's actually called a diagonal. Diagonal, bisects angle in half. It cuts angle right in equal halves. So definitely that means this diagonal has cut this angle into two equal halves. That means, and we've already known that this is already 30. Definitely this is going to be what? Another 30. All right. So this is already 30. This is going to be another what? Another 30. So triangle. So um let us see. Angle ADC is going to be equal to what? This y plus what? This 30 plus what? This 30. The second 30 here, which is going to be here. All right. And that's going to be what? Y is already what? 30. So we have 30 plus 30 plus 30. And that's going to give us what? 90 degrees. So angle ADC, which is this angle, is going to be 90 degrees. Thank you very much for sticking around. Try and stick around for more wire questions such as this, especially in this particular topic. Thank you very much.